Hello everyone. Once again, welcome to Engineer Dove's tutorials. Okay, so this day we'll solve problem. This is an example. We will solve problem now using the method of sections. So here's the problem. Using the method of sections, compute the force on member GH and CF of the truss shown. So member GH, this one, and CF, this one. Okay. We will solve first the reactions, support reactions. Okay, so at point A, point A is hinge support, so we have two reactions, vertical reaction and horizontal reaction. And at point E, so point E is a roller support, so we have only one reaction, a vertical reaction. Okay, so taking moment about point E, we can get the magnitude of RAV. So a summation of moment about point E equals 0. So RAV about point E is clockwise moment, and while 35 kilonewton and 10 kilonewton are a counterclockwise moment about point E, or negative. Okay, solving the magnitude of RAV, we have 31.25 kilonewton. And summation of moment at A, this one, the same process. So we can get the magnitude of RE. Okay, and by inspection, since there's no horizontal applied load, RAH is equal to 0. Okay, so at section A, so this one, no? Section AA. So we have three forces, no? Member, or the force acting on member BC, CH, and GH were exposed. Okay, so we have three unknowns, and because this free body diagram is non-concurrent force system, so meaning to say the three equations of static equilibrium can be used, no? So we have three equations, we have three unknowns, so we can proceed with the analysis. Okay, okay, if we will take moment about point C, this point, to we will identify the forces that can create moment about point C. This FBC and CH, this will be eliminated, no? Since the line of action of these forces passes through point C. Okay, so about point C, we have FGH, no? FGH about point C. This is a counterclockwise moment, and as we can see in our equation, FGH, the moment produced by force FGH, is negative. Okay, and we have RAV. RAV. Okay, RAV about point C. This RAV can create a clockwise moment, and its moment arm is 6 meters, 3 plus 3. Clockwise moment, so positive. Okay, and 35 kilonewton force about point C. This is a counterclockwise moment about point C, so negative. Negative. This RAH is equal to 0. Okay, and we get the magnitude of FGH. Okay, and considering the free body diagram of this free body diagram at section BB, 3 forces were exposed, no? FCD, FCF, FGF, and it is asked in the problem the force on member CF. CF, how to solve this one? By applying the summation of forces vertical, considering this free body diagram, no? FCD and GF are horizontal forces, so the only the forces that have a vertical component are FCF and RE. So summation of forces vertical is equal to 0. RE is upward, 13.75 kilonewton, so positive. Okay, positive. FCF, or the vertical component of this force, since we have the value of angle theta, so the vertical component of this force is negative, no? Downward, negative. So solving for the magnitude of FCF, we get 17.19 compression. Okay, thank you.